Hello everyone, this is the video solution for CodeZest Division 1, question number 3, Tingu Master does repairs. So in this question we are given that there are X square shaped tiles which are arranged in a row. Out of these X tiles, the Y number of tiles are colored blue. The number of blue colored tiles may be 0 or anything up to X. Now the condition given to Tingu Master is Tingu Master has to paint exactly D tiles at one time. That is, one paint job includes coloring D tiles at one time. Now the condition for D is D can be any number of consecutive tiles, but the consecutive tiles should not include blue color tiles. So that is, Tingu can color white consecutive tiles. So we need to fix a value D, and in each paint job he can color D white tiles. So the question here is at least how many times he needs to paint the tiles, that is the number of paint job requires, so that no white color tiles remain. So let's take an example input. Let's say we consider this input, that is x equal to 13, that is the number of tiles, y equals to 3, that is the number of blue colored tiles, and the tiles that are blue, that is the 13th, third, and the ninth tile is blue. So let's consider the scenario first. So here you can see that there are 13 tiles, out of which third, ninth, and the 13th tile is blue. This is the input that is given by the question. So in this scenario, you can observe that Tingu can paint the white tiles. So first we need to decide a number D. Suppose let us take the number D as 3. So in one paint job, Tingu can color 3 tiles at a time, not more, not less. So in first paint job, suppose he paints these tiles, then coming to these white tiles. In the second, this in the third, he cannot paint 7 at 9, but he can paint 6 7 8. So initially 10 11 12, 4 5 6, and then 6 7 8, but he cannot paint 1 and 2 in any way because the D is 3. So here it is evident that we need to take the value of D, that is the number of minimum number of consecutive white tiles. So here we have it 2, which is evident from the figure. So if we consider D as 2, we have first pin job here, that is 1 2, second 4 5, then 6 7 7 8, that is 1 2 3 4, then here the fifth and here the sixth. So minimum number of paint jobs that are required is 6. So the output here we have is 6. So let us see the logic here. Now suppose we count the number of white tiles that are there between the blue tiles. So consider the tiles between 3 and 9, third tile and ninth tile. We have 5 tiles, so we have stored it in number of white tiles. Then between 9 and 13 we have 3, so we have stored it. Now considering the extremities, that is the number of white tiles to the left of the first blue tile and number of white tiles to the right of the last blue tile. So before 3 we have 2 tiles, that is 2 white tiles, so we have considered 2, and after 13 we have 0, we have considered 0. Now the smallest number amongst these is 0, but we cannot color 0 tiles, so we are considered the first minimum element which is not 0. So we have 2 here, so we have taken D as 2, and eventually we get the answer as 6. So let's take a look on the logic of the question, that is the code. So yeah, so in the code here we have declared the necessary variables, that is x and y, that where x is the number of tiles and y is number of blue colored tiles. D equal to 1. Now we have considered D as 1 because the minimum number of tiles that can be painted at one time is 1. We cannot paint 0 tiles at one time. So we have considered it as 1 and the answer as 0. Now answer is 0 because there is a possibility that uh, there might be all blue tiles. So there is a 0 number of paint jobs required to paint them red because blue tiles cannot be painted red. So that's the initialization. We have taken the input, then declared two vectors, that is blue tiles index with a length of y. Y is the number of blue tiles to store the indexes of blue tiles, and number of white tiles, that is with a length of y plus 1, because let's consider this case. We have three number of blue tiles and the number of white spaces are 3 plus 1. That is, this is the first space, this is the second space, this is the third, and here we don't have actually any white space after 13, but there is a possibility that here there might have been a white colored tile. So that's why we have taken m plus 1 as the size of number of white tiles vector. So yeah, moving forward, if y equal to 0, that is there is no blue tile, all tiles are white, then d can be x, d equal to x, where Tingu can paint all the tiles at once. So the only one paint job is required. So here we are printing one directly and we are returning the function. So this is a test case or end case you can consider. Now, okay, so if there are some blue tiles, then taking the input for the positions of blue tiles, as we have here 13, 3, and 9. Then after taking them, we need to sort the blue tiles. Now, after sorting, we have here 3, 9, and 13. Okay. So now we need to consider the number of white tiles. So initially, counting the number of white tiles between the blue tiles. So now here we have the loop starting from I equal to 1 and going to y minus 1. Now here if we start from I equal to 1, now here the pointer points to this, that is 9. So we will consider 9 and 13. Now, sorry, we will consider 3 and 9. So here we have number of white tiles in I minus 1, that is number of white tiles of 0, the first position of number of white tiles, equals to blue tiles index I, that is blue tiles index 1, minus blue tiles index 0 minus 1, that is we have 9 minus 3 minus 1, because we are excluding both third and the ninth tile. So we have blue tiles index I minus blue tiles index I minus 1 minus 1. So we calculate the same for all the elements of blue tile position. So we calculate between 3 and 9, that is 9 minus 3 minus 1, that is 5. Then we calculate between 9 and 3, that is 13 minus 9 minus 1, that is 3. Then considering the extremities as said earlier, so the extreme left condition, that is the first element minus 1. So here we have 2. So we have two tiles and the end case. Now here in end we don't have any tile, so we have 0 here. So these are for the extremities. Now sorting this number of white tiles. Now after sorting, the this number of white tiles will become as 0, 2, 3, and 5. So now we need to decide D, that is the number of tiles that can be painted in one paint job. So now we will consider the minimum element from the vector, but considering that it can include a value 0, we are iterating in that vector and checking that if number of white tiles is not equal to 0, then we declare the first element whichever is non-zero as D. So in this case we will have 2 as our D. So D equals to 2 and we break from the loop. Now here we have for iterating number of white tiles. So we are iterating in number of white tiles. So here we need to take the seal value, that is, now in this case consider here we have two white tiles. So in one paint job this can be done. Now here we have 1, 2, 3, 4, 5 white tiles. So this can be done in 1, 2, and 3. That is 5 divided by 2, that is 2 in the case of integer, plus 1, that is 1, 2, and 3. So this is what we are trying to do here, that we have declared answer as 0 initially. You can see it here. So answer equals to I, that is the element of number of white tiles, divide by D, that is 2 in this case. So yeah, so now let's and if I mod D, that is the remainder, is not equal to 0, increment answer. So now let's consider this. Now if we move in D, initially we have 2, so 2 divided by 2 is 1, so in this case we have 1. In this case we have 5 divided by 2, that is 2, and 1 as a remainder, so we increment 2 by 1, so 1 plus 3 plus 2, so we have 3 plus 2 plus 1, that is 6. So that's why we have the answer 6 for this particular test case. So this was an approach for finding out the number of minimum number of times the tiles need to be painted, and then we have printed the answer. So let's run the code and try it once. Yes, you can see all the test cases are passed. Yeah, so thank you.